Okay, so this next video will be about Mohr circle. Mohr circle is a tool for transforming tensors from one coordinate system to another. Obviously, there's a lot of other ways you can do it from linear algebra, but the fact that stress is symmetric, because you have like your shear stress in each direction. So let me draw that out really quickly. So remember we said that the shear stresses have to look like something like this. So that means that sigma 1, 2 equals sigma 2, 1. So stress is a symmetric tensor, right? It looks something like this. I flipped these. All right, there we go. So it's symmetric. And when it comes down to it, that's why Mohr circle works. In matrices that aren't symmetric, there's a lot of other issues that you have to deal with. And so you can do it the linear algebra way, but the circle is really nice. It comes from like actual properties of this matrix. Anyway, I'm digressing. So the goal of Mohr circle now, say we have the stresses in this blue coordinate system, and we want to get the stresses on the red element in the red coordinate system. So let me write that out. So I'm going to briefly hint about where you actually derive these. So I just wrote it down here. I had recorded a version of this video where I did the full derivation, but it's really not that interesting, I gotta say. And you definitely won't have to do anything like that on the exams. So this is just for anyone who wants to like extra. I don't know. Do you decide to looking at this stuff? Basically, what you do is, for example, you write E1 and E2 in the blue system in terms of the basis vectors for the red system. And then you can write a transformation like this, where you have the stress in the red system is equal to the stress in the blue system multiplied by these matrices. And then you go through and you do all the algebra, and you set the new shear stress component to 0. If you're, so for example, we're trying to diagonalize the tensor. So we would get like, when you do that anyway, you end up with this. And this is the equation of Mohr circle. So now that explains where this like 2 theta comes from. Okay, getting ahead of myself again. Let's show how to actually use it. So let's say we have here, we have sigma and tau. And say we have, again, some stress. Strain would be the same, exactly the same. So what we're going to do first is we're going to find the center of this. And so that'll be the average of sigma 1, 1 and sigma 2, 2. And we can just go ahead and plop that right here. And then now we want to find the 2 other points that we would get from this. And so the way we would do that is we go up here and we take the difference between sigma 2, 2 and sigma 1, 1 over 2. And we do this 0. And then we're going to put in the sigma 1, 2 as well. So basically, this is our center here, and we're going to go from the center, and we're going to add the difference between the 2 of these on the x-axis. Then we're going to add the shear stress on the y-axis. So let's say that puts us right here. Up 3, down 2. So if we draw a line through these 3, that's now the diameter of our circle. So if you wanted to actually go through and calculate this, you would see that the x section here, this is our sigma 2, 2 minus sigma 1, 1 divided by 2. And the y part is our sigma 1, 2. And so if we now calculate the radius of the circle using this, so we would do sigma 1, 2 squared plus sigma 2, 2 minus sigma 1, 1 over 2 squared. And then you take the square root. That gives you your radius. And then you can use that, and you can imagine having now the red coordinate system out here at your radius from that distance. And so now we can just draw the whole circle, basically, through here, all the way around. This might not be a good circle. And so one last thing to look out for is this angle here is actually 2 theta. And you can see where that comes from now, because you didn't do these derivations, but you could. When you finish it up, you end up with this equation, and you get the 2 theta in there. So what that means is that when this rotation between these is theta, you actually, on your Mohr circle, it's going to be 2 times that theta that you're dealing with. And so at the end, after all this, we got the same thing you could have gotten by hitting the eigenvalues button on your calculator, which is we got that sigma 1 is equal to this radius, basically. So it's going to be equal to, so this is our first principal stress, our biggest one, is sigma 1 plus sigma 2 divided by 2. So the average of these two plus the radius, right? And then same thing for sigma 2, except it'll be negative. Plus minus the radius. So that'll be out here somewhere. Great. So now we've written in this red coordinate system, we have sigma 1, sigma 2, and 0, 0. So we've diagonalized the matrix. That's great. It makes a lot of things a lot easier. And yeah, so that's the story. In 3D, it's much the same. You can do it along each component separately, and happy to show you how to do that in office hours if you want.